Hello, my name is Ian Pena, and this is Physics Lab 2, Lines of Charge. So the purpose of this lab was to use our data found in Lab 1 to describe the charge and forces of the electric field produced by each charge tape more accurately, as now we would treat them as a line charge instead of a point charge. The principles of this lab are similar to those of Lab 1. We use Newton's second law to describe the forces acting on the system that are equal to mass times acceleration, and we use superposition of these forces to find the net force of the whole system. We also use Coulomb's law, which describes the force that charges have or charges create on objects. So to preview our findings of this lab, we found that when treating the tapes as line charges instead of point charges, we found that the magnitude of the charge of the tape is equal to 1.498 times 10 to the negative 8th coulombs. And with this new charge, we were able to find that the electric force of the bottom tape onto the top tape is equal to 1.912 e to the negative 3 newtons. And we found these two results with the following assumptions. We assume that air resistance can be ignored, and we also had to treat each tape as a line charge where the charge is evenly distributed throughout the length of the tape. And each tape is also made with the same charge. So we consider the top tape to be the system and the bottom tape to be the surroundings. And the experiment was similar to this graphic where we held the bottom tape to the top tape and measured the distance between the tapes when the top tape began to levitate. So the experiment found that the charged tapes were positively charged as they attracted to a negatively charged pen. And the initial conditions of tape B in this case, we found that the length of the tape was 0.195 meters, the width being 0.01905 meters, and the mass being 0.000195 kilograms. And the distance we recorded was 0.01 meters from when the top tape began to levitate. And this original experiment found that the charge on the tapes was 4.61 times 10 to the negative 9th coulombs. For this lab 2, we created a brand new lines of code. So in this first image, we have a bunch of constants and initial values, and at the bottom here we find the E field of the each particle in the tapes, the E field of each particle on the top tape. In the second image, this was the code provided to us that basically basically converted the point charges to a system of line charges or a system of a line charge, as there are multiple point charges within the tape. This top image basically it shows how we found the E field of the bottom and top tape and then we also find the force of the bottom tape on the top tape, and we add both of the forces here to total them together using superposition. The bottom image over here basically explain or creates the graphic that is on the next slide, showing how each point charge that makes up the line charge of the bottom tape has affects each point charge in the line charge of the top tape, showing its E field. Um, this is the graphic I was referring to. So we see that the electric force is equal to the force of gravity, and you can see like each of those green arrows shows the direction of the E field on the top tape due to the bottom tape. So the possible sources of error from this lab could come from the lack of using insulated material to handle the tape, which could disrupt the charge of the tape as it might dissipate into my hand. And then another possible source of error was that the tapes weren't created with the exact charge when ripping the tape off of the bottom U tape. So that might cause some discrepancies between the experimental and the computational model data. So the what if question, what if we had modeled the tapes as single point charges? Well, this is what we actually did in the first lab, and we found that the charge of the tape was 4.61 times 10 to the negative 9th coulombs, while using a line charge model, we found that it was 1.498 times 10 to the negative 8th coulombs. So we found basically that the charge is actually greater in this second lab. And these estimates differ because basically in the first lab we had concentrated all of that charge into a single point, and it wasn't as complex as it is in reality. And so basically this lab kind of shows us a more accurate representation of what the charges would behave like from the bottom tape to the top tape, meaning that the value 1.49 is actually more likely to be closer to the real value. So thank you for watching my video.